I'm using this hypothetical company called Ridgeline Mountain Outfitters. So that's the case study used in this prescribed textbook throughout the whole chapters to explain the different concepts. So I use the same material to discuss the concepts related to the requirements modeling. So the about this company, what is this company is about, what's products they are selling, what's their sales strategy, what their systems they are currently using. I have a kind of small video. If you want, you can watch it, but it's not compulsory, but it's advisable. Okay, right. Okay, so let's go to the lecture. Right. So last week, so do we have any questions, guys? So far, you guys, can you please tell yes or no? No questions. Then I can move to the lecture if you don't have. So otherwise, I'm more than happy to, all good. Okay, how about others? Others? Harry, Sarah, Liam, Yi, you all good? Okay. Imran. Okay. All right. So last week, what we have done, we studied, what do you mean by system analysis and design? What is system? What is system design means? And who is system analyst? And what is their task, right? What skills they need? So we actually learned the basics last week. Okay. So this week we are going little down, and we are trying to understand what kind of approaches that we can use when it comes to system development activities, and what do you mean by this system development life cycle is, right? SDLC. What is system development life cycle is? Okay, so today's we are going to actually focus in these key areas. So what is the so-called system development life cycle, and what kind of processes involved in that SDLC? We sometimes call SDLC, okay? And okay, so today we are going to the system vision document as well. What is system vision document means, and what approaches we can use when it comes to SDLCs. So we basically have two types of approaches: adaptive approaches as well as predictive approaches. Okay, so depending on the context or depending on the project that we are dealing with, we can decide which approach we are taking. And what are the characteristics of so-called iterative system development? What do you mean by iterative development? What are the basic characteristics? Okay, and how are we going to develop the systems, etc., etc. So before that, we need to understand system analysis and system design. When it comes to these two things, actually is mainly driven by the methodologies or the techniques, models, tools that we have adopted. Okay, so every system development, I would say system analysis and design projects has its own kind of techniques or the models and tools. So what do you mean by each of these? So let's go through the briefly. So when it comes to system development methodology, we can say it's this is how we define by Addison and Fitzgerald. It's a collection of processes or procedures or techniques and tools, and also the documentations, which actually guide system developers in their effort to successfully develop the information system or any application, I would say. So these methodologies consist of processes, or we can sometimes call as phases, right? And also sometimes we may have sub-processes or sub-phases, which basically give a kind of a guiding, steps for system analysts and system designers to choose which techniques that which tools they can use, or which techniques that they can use in at each stage or each process in the project, because it will give them a kind of an idea to successfully manage the project, successfully plan the project, or to implement appropriate control methodologies to see whether the projects are in the right direction, in other words. All right, because we don't want the projects to off the directions. We need to keep that on the track and see whether it's actually progress as we planned. So basically, the methodology is like that, right? It's a collection of things like procedures, techniques, and tools and other documentations. Okay. So the basic idea of the methodology is to make sure the project is not going off road, keeping the track and flows as we expect. But of course, in IT projects, it's very difficult to predict, right? Because the nature of some projects are very complex. Sometimes external, environment can change. You can know that nowadays the hot topic is now there is a kind of a uh, problem is going on in Eastern Europe side, right? War between Russia and Ukraine, and actually it's impact the business, how the business are dealing and how their system need to be interact because of the government sanctions and conditions. So how is we have to be very careful about developing the systems in these kind of uncertain conditions. So that's why we need to have a better system development methodology. So what do you mean by the models in these in methodologies? So models, I think you already use models. We use the diagrams, charts. We trying to actually represent important aspects in the real world by using some sort of a models. Like we use the entity relationship diagrams to model the data processing aspect of the system, right? Or maybe we can use some other like system like project planning system or project planning models or budgeting aid models to show the financial aspect of the project. So likewise, models are actually plays a very important part in any system development projects. So what are some examples? So these are some examples, some visual models like data flow diagrams, which we are going to learn shortly, maybe another couple of weeks time. And then we know the interrelationship diagram. That's another model which actually shows how the data is used in a particular system. So likewise, we have class diagrams, use case diagrams. So they actually shows the different aspects of the project or the product that you are actually trying to deal with. And there are some models used to manage the development processes, like we use the Gantt charts, organization hierarchy charts to show kind of how the working relationship works, or how we use the financial analysis models to calculate net present values and return on investment values to see whether the projects are profitable or not. So some models are we directly used in the system components, while some models like NPVs and ROIs are used to for the project management purposes. So each methodology actually has their own models, right? For example, there are some methodologies we can actually buy off the shelves, sometimes thousands of dollars worth, right? It's a very expensive. It's not that easy. So those methodologies actually gives you some idea or the guidance how you're going to create these sort of models, in what ways, and what kind of software packages you can use, etc., etc. And also the methodologies contains tools as well. What are the software support is there to create these models and other required components of the project, right? We can have a complex program, sometimes if you do kind of complex programming stuff, we can have computer-aided system engineering tools, project management software, etc., etc. So these are some tools probably we can use in as a tool in system development projects. Code generation tools, reverse engineering tools, visual modeling tools, and even simple word process or word document is a tool as well, because we to document probably the business rules or other aspect of the project, right? We use graphic or diagram, we use diagrams.net. That's also online cloud-based tool that we can use to create models. And then of course the techniques we have, right? So techniques are kind of procedures or the guidelines that will help the analysts and other developers to complete the system successfully or in their daily development activities or the tasks. It give a kind of a step-by-step approach, and give some generic advice in some places, how to deal with some uncertainties, etc., etc. So some examples of techniques are, how you're going to interview, people, what are the interviewing techniques, or what are the project management techniques we have, right? Or design techniques or programming techniques, etc., etc. So when you collect all these models, techniques, and tools together, then it actually gives a comprehensive methodology for the system development activities. Then the next question is, why actually we bother about to talk about this, or why we bother about to focus on these methodologies? Because there are a bunch of advantages to use of this development methodology, right? It will give a systematic approach for the development, um, because we can actually maintain the also the consistency of information system development activities, because if you have these tools and procedures in place, so every piece of the project is recorded methodologically, so it can be easily communicated without having any confusion with the other parties, right? So there kind of a systematic approach is there. And then the maintainability is very high, and because it's a well documented system, right? So if you need any enhancement to the system, the documentation already there, the processes we followed, procedures we followed is already documented, tools that we use already documented. So the enhancements can be done without having any issue, because that proper control documents there. Improved quality controls and the standards, that's one of the basic advantage having a systematic approach. Quality control is really important in any project. We don't want actually to produce some sort of a packages or application that produce a lot of errors. So we need to actually make sure that appropriate control mechanisms are in place and the standards are in place when the development activities are started. So that actually greatly help for us to have a better systematic methodology in place. So we can easily implement these quality control aspects or integrate these quality control aspects into the projects. And then the trainings will be training can be facilitated as well, because we can easily see which components are going to produce first, which components are going to produce next. So based on that, we can train not only the developers, but also we can train the users as well, right? So we know exactly which part are coming and implementing first, and then based on that, we can organize training accordingly. Um, it facilitates the project management activities very easily. We can establish relevant key performance indicators in all the project activities and monitor how the progress is working. uh, then the consistency can be implemented as well, because if you have systematic approach, then each and every project that we undertake can actually use this consistent approach. Then obviously it's come to the quality control part as well, because it helps to maintain the same level of quality across the projects that we are currently working on. um, and then learning and experience in use is another one, because properly documented systems and properly followed guidelines are there. Then obviously when the errors comes, we can properly update the existing methodology. That's the learning part, right? And obviously all of these will add some additional value to the final product the project is going to produce. That's the software application. So it will improve the product, and it will definitely improve the processes that that particular product follows. So that's the main reason why we need to follow a proper system development methodology. Uh, so the software development methodology, or software development or information system development, like as I mentioned in last week, how it's actually very quite similar to how system analysts solve the problems, or as normal person how we solve the problems. So we need to go through sort of a series of what do you call activities. First we need to understand what actually we are trying to solve, or what opportunity we are trying to uh, you know um, try to capture, and then we need to have a vision what we are trying to achieve, and then we need to define the solution little bit in detail. We need to communicate the vision and the solution. We start building the solution, and also then we need to find out whether are we actually build that according to as we have understood. So we need to have appropriate controls as well, because we need to find out whether we need this solution output as we expected. And of course we need to launch a solution later on. So the system development life cycle. So all these actually things pave way to develop the so-called system development life cycles. So system development life cycle, I would say, kind of a how we going to manage the project, or it's like a project management or project management. I would say it's a kind of a technique. uh, Basically how we going to build and how we going to manage all this building and launching and maintaining your application or information system. So that's actually explained by the system development life cycle. So any system has a life cycle, that's basic. So that life cycle need to be managed. So this system development life cycle basically has some several processes, that, or we can call it as core processes. Some people call it as phases, right? So basically, it will give you kind of an idea how we progress from one core process to the next core process, and from next core process to the other core process, etc., etc. So the basically the textbook that we are referring, they I follow their methodology. They use a 6 core processes in system development lifecycle. So basically some books actually it's has 5, or five or four, but this book uses 6. I stick with the book that we are using, right? So it's the methodology that we use in SDLC also. It's very quite equivalent to the methodology that we usually use to solve a problem. Okay, these are the 6 processes. So we'll go through one by one later on. But before that, we need to understand what is the project means, because we are dealing with a project. Software development or application development is a project, right? So how are you going to define a project? So if I ask a question, what is a project means? The project is actually planned thing, right? Planned undertaking, right? So it has a beginning, and obviously it need to have an end, right? And it also need to produce some kind of a definitive result, right? Otherwise it's not really a project, right? So project need to actually have a result. Okay. So we use this concept to define or the project in IT or information system development. So obviously in IT context or IS context, we need to know various tools and techniques used in system analysis and design in order to understand system development life cycle. So as I mentioned in my first class, we in the series of this lecture in 11 weeks, and in the coming 11 weeks, I'm using Ridgeline Mountain Outfitters case study, or sometimes when you see RMO, so that's the acronym we use. So Ridgeline Mountain Outfitters is a fictitious company based in US. Um, so they have actually a couple of problems. So they have these old fashion, systems that they wanted to upgrade or integrate. I would say they're coming a bunch of, applications. And also they have another problem, the trade purchasing agent. So it's a clothing company. So there are kind of merchandisers going around the world, or they call it as purchasing agents. They going around the world in different trade shows to source, the latest fashion trends or sporting fashion trends to their company. So they have kind of a problem of, bringing all these latest information back into the office. So they didn't have kind of a proper system to capture, latest trends and supplier details and then the product details. And because the system they existing have is kind of a manual, they just go there and then communicate with appropriate suppliers and come back to the head office and then come. So they want a kind of a real, real time system that they can, instantaneously, upload or update the system from where they were, and instantly send this information to the head office. Okay. So that's the problem they are currently faced. So they need a information system or application to track all these information regarding products and supply while they are in the trade. So that's called the trade show system. That's how the trade show system actually emerged. So they basically, that project, they broken down into two sub parts, like, or we'd say the subcomponent. Remember the subsystems that we discussed in week one. So they wanted to develop these two subsystems inside the trade show system. One is supply subsystem, and the other one is a product information. So all the product related new products and all the product details and, you know everything, pricing details, it goes to the product information subsystem, whereas all the supplier related details go to supplier information subsystem. So that's what they mean by the trade show uh, project needs. That's what they are proposed. um, so the system development life cycle, so developing a system like that, a trade show system, so they need to go through these 6 core processes. Okay, so they first identify more thoroughly the problem or the opportunity, and they need to take the approval from the management, right? There is a process that we need to go through, there are documents that we need to prepare for it because it's a formal project. And then we need to, establish a proper project management, activities or kind of a process to handle it. and proper mechanism to monitor how the project is focusing. And then we need to kick start of the project, right? So we need to dig deep into the problem or the opportunity to understand in detail the activities or the functionalities that we need to represent in the system. So that's what we are focusing on this subject. The third part is what we coming 11 weeks focusing, how we are going to understand the details. And then the design parts come, or design activities comes next, right? System component design, what communication we need, and what are the hardware parts we need, etc., etc. And then of course we can actually execute or the build and the test and integrate the components, and finally can deploy the system, the solution, or implement the solution. So you can see that there are 6 core processes involving in developing the system like trade show system. Um, I'll come to these iterations first later on. So just remember these 6 core processes. So if you go one by one, I'll go one by one. So the first thing is identifying the problem. As mentioned before, I would say this is a pre-project activity, because before we committing our resources to the project, first thing is we need to make sure we identify the problem or the opportunities correctly, right? Um, that's something actually is very critical, because if you don't understand the problem correctly, and then if you allocate the resources, then it's a waste if you're not getting the right correct results, isn't it? It's a waste of time, waste of resources. So the resource allocations very costly nowadays, right? So we need to manage it properly. So that's why we need to identify the problem and or the opportunity properly, and obtain the proper approval from the top management. So there are various activities comes under the first core process, I would say. First, we need to define the problem or identify the problem, and we need to use certain techniques to try to quantify the outcome of the project, or we can call it as quantify the project approval factors, right? Because we need to calculate from the financial perspective, whether it is a viable project, right? What's our return on investment? How it will increase or enhance our revenue targets, or how it going to assist to reduce the cost. Okay, and then of course once we done that, we need to do a kind of bit of a feasibility study as well, uh, uh, risk analysis, I would say. There are various risks can be impact the project performance in future. It's not from the financial perspective, but there are other things that we need to consider, right? Organizational culture, does it actually support this kind of new application? Who knows, sometimes our culture or the teams that we are trying to implement the system may be not really happy with the new system. Maybe they may think it will reduce their power in the company, right? Or sometimes social factors, sometimes other environmental factors, or legal factors. So there are various constraints there. We need to do this sort of feasibility risk analysis to determine whether we can actually commit the resource and go ahead successfully. And then of course we had to actually get the approval after we reviewing it with our sponsor, the project sponsor. Project sponsor can be the head of the department, or maybe another middle-level manager in the organization, or anybody who has directly linked with the project, probably the client, right? So we need to review with them and then obtain the approval. So you can see kind of these pre-project activity, there are a lot of things involved in there. Uh, in my previous experience, I actually work in the industry. Majority of my business analyst work actually focus on here because I'm coming from the management accounting background. So I involved in costing the project, so calculating net present values and calculating return on investment. So financial perspective, I contributed in that area. Okay, and once we get the approval, right, approval from the management, we can actually establish the project uh, committee or the project what you call project itself and start going to the next core process. But before that, the one of the important document that we need to actually prepare in this core process or pre-approval process is so-called system vision document, because identifying the problem is really very important aspect, as I mentioned before. Um, um, so so I just going through this again. There are, I think I have already talk about these things. So what is this system vision document that we are trying to prepare, right? That's actually give a kind of an idea for the project sponsors. Uh, what actually the problem we're trying to solve, or what actually the opportunity we're trying to grab. So we need to give a little bit of a description. So in a typical system vision document, yeah, actually the system vision, these documents are very lengthy. But if you produce a summarized version, it typically consists of three parts. Okay, three parts. So we need to first give a kind of a description or problem, or what is the idea, or what is the solution we are trying to build. And then the capabilities we need to actually define in detail, or capabilities in other words means what functionalities that we are trying to implement in this new system, right? What should it reflect? Because when you define these functionalities, it give a kind of a boundary of the system. Now remember that I mentioned last week, right? System boundary is really important, right? So the when you define the capabilities more, more, higher level, it gives a kind of an idea what is the scope of the project, in other words. Okay, and then we need to actually tell or define or show what are the benefits of this project, right? What are the benefits that we expect that accrue to the organization if you go ahead with this kind of a project. So when it comes to the benefits, again, guys, we may have a tangible benefits which we can actually measure in dollar terms, but as well as intangible benefits, right? We need to tell what kind of intangible benefits, like for example, customer satisfaction or the user satisfaction, right? Which we cannot actually measure precisely using a dollar value. Uh, so we have to actually but tell them, right? These are what we expect as a benefits, right? So basically these are the three things we need to show in the system vision document. So this is what you need to do first in your project as well as a team, right? So I have given a case study, I have given a problem, or there may be an opportunity. You know the scenario, now you are working on that particular PDF document, but it's a very broad level, so you need to break it down into a component and see what is actually the problem or the opportunity they are trying to uh, focus on. Uh, so here I have here the example actually for the Ridgeline Ridgeline Mountain Outfitters, the trade show system. So they identify the problem, but they see how they have described the problem. They says that trade shows are really, actually trade shows are very one of the critical aspect of the aspect in the companies like RMO, because that's their core business, right? Um, so they need to actually capture these information with in new trends in the trade show, and it's very vital them to actually introduce these new trends in their clothing stores, because obviously sporting clothes and in these sometimes clothing, it's seasonal dependence, and it's has a expiry date, so it's very obvious they need to act quickly and introduce quickly as possible the right product at the right places. Excuse me. So they mentioned that in the problem statement, you can see here, and also they says it's recommended that the new system to be developed and deployed should be actually facilitate these a purchasing agents or the merchandisers to effectively communicate with the home office, with supplier and the product specific details. Sometimes the executives back in the head office, they can make a very quick decisions, right? So they need to have those information synchronously supplied to them. I mean, if they can make a decisions quickly, and they can actually sign the agreement, or they can make a deal with these suppliers at the right on the spot. So that's actually described in the problem description. And then the system capabilities give you a kind of a what. So to achieve that vision or the capability or the vision, I would say, what functions we should actually demonstrate the application, in this case the trade show system should reflect on, okay, or what functions. So they actually identified bunch of functions or more higher level functionalities, like the system must should support or collect and store the information related to suppliers. They should be able to store the information related to the products, right? Etc., etc. And then the system must able to communicate via the Wi-Fi system, etc., etc. And also they have identified the benefits. If you implement these capabilities, what benefits you can actually expect for the ridgeline mountain outfitters, right? So they basically identify these qualitative benefits, bunch of qualitative benefits, as well as I think the quantitative. They haven't actually mentioned the quantitatively, but they mention it in more broad sense, more broad terms. So in this couple of slides, I just break it down the same content. So I just skipping. Um, so now system capabilities section is really important. This is where now in your project, your case study, this is what you need to focus on. When a team, for example, if a team of three develop these capabilities, maybe three of you maybe separate each capability and focus on one capability in future development, right? In future, the RAM project purpose. Okay, so that's what I'm right making. Maybe sometimes you may focus on a couple of capabilities or more than two. That's fine. Uh, so the capabilities section is very important, and the benefit section is also important because it shows the real advantage for the organization. So these two have kind of connection, but they are not equal. They are not, doesn't mean that they're both same. As I mentioned before, capabilities are functionalities that supports the business activities or business procedures, whereas business benefits are the things that we can measure in the dollar terms, that brought to the organization by this application, or how they increase the revenue, reduce the cost, etc., etc. So essentially, we can say if you implement these capabilities, these are the benefits we expect, right? That's how it means. This is what it means. Right, right. So that's about the core process one, or the pre-project one. So as a result, we produce this system vision document. We then put into the board of directors or project approval committee, and then they will give an approval for the project. Then starts the second core process, right? So the project planning phase, planning and monitoring phase, I would say, because this phase or this core process or this phase, I would say, it will actually span throughout the project until the project ends, right? So what are the things involved in the second core process? Okay, so basically, it involves three things, right? We need to determine the major components, what are the major functional areas that we need in the project, and then we need to define how many iterations that we expect in the project need to go through each activity, right? And how we're going to assign the functions to each iterations. So I will come to the iteration later on, okay? And then we need to determine who are actually undertaking what, how we going to assign the responsibilities, who are taking the development activity, who are taking the admin activities, etc., etc. Um, so so for the RMOs, this trade show system, so they just broken it down into components. For example, as a first part or first core phase inside the project manager. So they determine two subparts, so two major components they require, like supplier system and the product information system. And then when it comes to define the iteration, they need to go through each subsystem and see, and also first they need to decide which subsystem they need to develop first, right? So they can't start the both subsystems because it's interrelationship. So supply subsystem they decided first need to be started before the product, because suppliers need to be identified and recorded before we identify the products, because there is an instance related with the supply, right? And then we can decide how many iterations, how many cycles we need to go through all these six core processes um, to complete the sub project or the sub system. So you can see here the iteration means um, times that we need to go through each core process over and over again. So they believe we need to have, if you break it down into six, so one iteration maybe 30 days, or maybe who knows, maybe a couple of months sometimes, right? So you can see here iteration one, there are kind of highlighted areas. So what we mean by this is, first iteration in the project, we put much effort in identifying the problems and obtaining the approval from the management, right? And planning the project, okay? But we put less emphasis on, but still we put emphasis, but lesser emphasis on, understanding more details of the project or building the system component, etc. But when the project progresses, when the iteration progresses, you can see the emphasis also goes in the other direction. Okay? So when the end of the project, our mainly we are focusing on building and testing the system parts. Okay, but the project planning component, so planning or the project management activities, you can see it goes throughout the project until it ends. Okay, so that's core process 2 is basically a planning and monitoring part. So we need to actually establish KPIs or key performance indicators in this stage as well once you start the project. So how are we going to evaluate the work processes? How are we going to monitor the work processes? How are we going to make any corrections, etc. So all these bit and pieces need to be properly managed, documented at this level, at this phase, okay, before we kick start of the project. Um, yeah, so one of the key actually output of first core process is called system vision document, as I mentioned before. So that system vision document is a sort of a kind of a document that used to plan the project, and then as a result of planning core process, we also develop bunch of other documents. Among that, one of the key document that we prepare is the work breakdown structure for each iterations, right? So it basically describe what works we need to undertake in each iteration, and what activities of each core process we need to focus on. So this example is given, and then it's also give a kind of an idea how long it will take in each activity to perform, etc., etc. So this is just a simple breakdown structure. So in your project, you don't need to actually do any work breakdown structure. So I want the system vision document to be built for that particular project. So once we uh, finalize the work breakdown structure, we know exactly what activities in each core process need to be performed and how long it will take. We can jump into the third important, I would say, the most important core process or this phase is called system analysis phase, or discover and understand the details. Now this is where we dig deep into the problem, right? We dig deep into the capabilities that we identified in our system vision document. Okay, so we gather more detailed information. We can actually interview the people, we can go through the documentations, and then we are trying to define the requirement more thoroughly, more adequately, I would say, as long as we try to prioritize these requirements as well, because we should not be able to actually achieve entirely all these requirements because we have limited resources, right? So we need to actually use a methodical approach to prioritize the requirements in a way that I will balance the resource requirements as well as the system vision. And also, we develop these so-called some sort of user interface dialogues, uh, because we need to capture the data in the system. So we can have a kind of a preliminary, better to have a preliminary idea how we capturing this data. So the interface dialogues has to be designed at the initial phase, at this kind of a stage, because it kind of give an idea what kind of database that we need to design. Okay, and then of course we need to evaluate all these things with the users to finalize the final set of requirements. So as a part of this project, here we develop so-called use cases or the functionalities we call, and use so many diagrams like use case diagram or data flow diagrams to show processes and various connection points, and then the class diagrams, etc. We will learn all this. So majority of our, or I would say almost every part in our lectures and this semester, our focus is with this core process or system analysis focus. Excuse me. So that's why we call this subject as requirement analysis and modeling. Right, we are focusing on that entirely 11 weeks. So we are going through um, these activities, and then excuse me, guys. And then it comes this fourth core process. That is where the system design phase comes into play, right? So this is where we trying to develop more in-depth screens and layout or report sketches. So we need to fine-tune these sort of things, because so we know exactly which components that we need to prioritize in how actually we need to produce the output to the back to the users, and how we're going to capture the information from the users to process the information to solve the problem that we have identified. And also we design the database schema, fine-tuning our ERD diagrams, and try to create the schema at this stage. And we design the system's high-level structure, which components come first, and how these components are related to each other. And then also we can decide whether the application is uh, which kind of operating systems we can, or is it a browser based, or it's a universal, or can be operating in small devices like smartphones, etc., etc. And also all these networking stuff, or are we going for the cloud based system, or are we the system based on the cloud system, or all these kind of technical things need to be designed in the design phase. And also we put a lot of emphasis on system controls, on the security at this phase. um, how you're going to protect your data. Okay, so if the system breaks down, how are you going to recover your data, etc., etc. So that's something we need to carefully plan and carefully manage, this recovery. So remember, now there's something the students often make mistake when you are trying to define the requirements in your project. Don't use like requirements like recovering the data, password protection, logging issues. All these things actually a core process 4 job activities. So we sorting out that in that core process, but not in core process 3. That's something you need to remember. And then comes the next core process 5, implementation side, right? We program the software, we build the software, and then we do a kind of testing. There are multiple tests that we need to do. We do, I'll actually explain this maybe later in the semester. We do the unit tests, and we do the user acceptance tests, um, uh, and then see whether there are kind of errors, and how we're going to rectify the errors. And then we building test cases, and then we trying to integrate small component of the systems that we built into a one integrate into a one component. um, so that's all point of implementation actors, and we'll decide whether we use our system as a cloud-based system, or standalone system which operate in each PC. So all these things are implementation activities. Um, and then the final core process is deployment side, right? So once we implement our application using defined technology, and testing it, and give a green light, then of course a deployment start, right? So before we deploy the system, we need to actually go through some set of other activities as well, because We don't know whether this application can handle all our transactions. We don't want to crash this system middle of the processing more important piece of information. So we need to do some kind of system and stress tests to see whether the application can handle the bunch of transaction or concurrent transaction or bulky processing kind of things. uh, do another set of acceptance test, user acceptance test. Actually, the earlier test I mentioned before, called the unit test, is a programming test, but the next level of test is coming on here, called the user acceptance test. That's where the users who are actually using the system need to get approved. Okay, that's what I am looking at. That's called the user acceptance test. And then the converting the test data to fit into the existing system, the new system. So conversion of the data is also a kind of a very painful thing, because it's really difficult to convert the old data to the new system. Maybe the fields are different, the columns may be different. So that's another, very complex activity, I would say, time consuming activity that system development projects will face. And then need to build the training programs for the users and conduct the training and build all the training materials. And then of course we need to configure and fine tune it with suitable for that production environment, right? The environment that we trying to implement the system, right? um, because sometimes the menus or the reports that we generally implement may not suit a certain circumstances in that particular context. So we need to do a little bit of configurations as well. Then of course we can finally deploy the system for the final, in the production environment. So you can see kind of system development projects are kind of how complex is, right? It's not a kind of the way that we can go very straight. So we need to go through a lot of activities and the steps and the core processes, phases. It's not that simply we jump into a programming side once we identify the problem, right? So you can see this each core process, how many activities are involved and how important each of these activities are. And then it's not only that, once we actually deploy the system, then it comes to the another phase of the project. It's called the supporting phase, right? Because we need to maintain the system, right? So we may need to actually repairs, we need to do a bit of updates, sometimes small patches, because some users are totally unhappy with the menus, or maybe they when they start working, they may come up with an issue, that we need to be fixed. So maintaining the system is something regularly happens once we implement the system, right? um, so that's why we need to have a proper system development methodologies in place to minimize these maintenance activities. And then of course we need to enhance the system. We need to do kind of a small upgrade sometimes, or more small enhancements to expand the capabilities, or to sometimes face the challenges, as mentioned before. If it is a larger enhancement, then of course we need to restart another, or we need to create another system development, OSD. We need to go through another SDLC life cycle to a separate development project, because it's too large, too lengthy, too time consuming, too resource consuming. So that means we need a separate development um, uh, project. And then of course we need to support the users, as well. That's also coming as a support activity. We need to create a help desk and create a support system to support the users, because we need to have a reasonable things in place, because we can expect the user queries very often in the new systems. So you can see kind of a problem solving steps that I have discussed with you in the lecture one is quite similar to this, but here it's more complex in system development life cycle, right? Because we have complex intertwined activities in place. Uh, so we know SDLC, it's a how we manage the project. So what we expect, but actually how you how you approach a really how you actually implement this SDLC in the real life project. It depends on the characteristic of the project, right? So sometimes some projects are very predictive. We know exactly what sort of product or the software application we are trying to produce. But some applications that we are trying to produce, we don't have a specific, what do you call, we know the target, but it's very unpredictable, right? So we need to have more flexibility to be there, right? So therefore, SDLC life cycle need to be get adjusted based on these two. So therefore, we have predictive approaches that reflect the SDLCs in the different ways, and we have adaptive approach that reflect the SDLC in a different way. So it depends on the characteristics of the project, right? So if the requirements can be well understood, if the project has a very low technical risk, and if we can define all the functionalities well in advance, of course we can have predictive SDLCs, right? For example, say student enrollment system. So we know the enrollment system looks like. We know at the end we need to properly enroll the students into appropriate units and programs, and then fees should be associated with each unit, with each student. So these sort of projects are very predictive, because we can exactly predict, and also we know the technology, whether the system is a cloud based, or and whether it can be implemented in both cloud, a standalone app as a standalone application, or we can use it as a handheld device, that application. So it's very kind of it shows a predictive nature. But there are some projects are very uh, adapt kind of riskier, and the requirements are not clear. For example, the IT projects maybe are in scientific laboratories, or maybe NASA in US who are sending rockets to the space, or maybe the fire systems in the financial services companies, or healthcare, industry. So they are very unpredictable, unpredictable in nature, and higher risk as well, and higher resource consumption consumed project. So these projects are adaptive. So the SDLC core process can adjust accordingly. But most of the majority of the projects, I would say, kind of reflect both ends. It has a kind of predictive nature as well as adaptive nature nowadays. So it kind of sits somewhere in the middle, not in the ends. But we have still extreme predictive projects and extreme adaptive projects. So extreme kind of predictive kind of projects can organize their system development life cycle like a waterfall. So we call it as a waterfall approach to system development life cycle, right? Why it is a waterfall? Because we complete each core process and jump to the next core process, and then we complete that core process and then next to the next one. So in the waterfall of the characteristic is we can't go back, right? So once done, it's done, right? Once the project planning done, then we start the analysis, and then once we finish the analysis, we jump the design phase, and then once we finish it, the design phase is frozen, and we jump to the implementation phase, etc., etc. And then finally the system can be built and delivered exactly as specified in the at the planning stage. So that's called the waterfall approach to organizing or managing the project. Uh, yeah, so there are a bunch of problems in this view. Sometimes people call it as a traditional system development, but it's not traditional, but still majority of the government projects, something like that. And majority of the people, I mean, executives like waterfall. They love it because they can predict the resources. They can predict how much of dollars they can spend on the project. They don't want any uncertainties. Of course, otherwise they will get held responsible for that. So they want, so that's the problem in most of the IT projects. So the people or the executives, some management think little bit, they are more budget focused, cost focused. They love this sort of flows in the project, but reality it's really different ball game. Uh, the thing is this because the waterfall approach, the risk is if you have made a markup or if something goes wrong, it's very expensive to do the changes, going back and correct the stuff, right? Um, so therefore, we sometimes we narrowly define the roles, even the users and the clients, and these kind of methods actually focus on the deadlines, right? So we need to, especially in the government projects, they give a defined deadlines. We need to focus. We need to deliver on that phase. But we have kind of little flexibility in now in waterfall approach as well. So we call it as excuse me, modified waterfall approach, or we can call it as a waterfall approach with overlapping phases. So we build a little bit of flexibility, but still we assume that predictive planning and sequential phases, but the flexibility is there because why is flexibility is there? Because whilst we do say for example while we do the analysis, but we can actually start the designing phase at some point of time until then we can get a kind of a very better idea or good idea how the system components are working. And then while we are doing the designing, we can actually start the implementation activity. Little part of the system can be implemented, get users feedback, and do little correction to the design stuff. So kind of flexibility still can be implemented in this modified approach. But the newer version nowadays, or more advanced, or I would say new trend is now, because of the environmental uncertainties, um, use more agile methods. So in these methods, we use the term called iteration, as I mentioned before. So iteration means going through, we breaking down the system into component and try to solve the small component by component and try to solve the whole big problem lastly, right? Once you solve the small problems, then definitely your big issues can be solved without having an issue. So the iteration means each problem or small problem solved until it turn to the large problem is solved, right? So we go through these 6 core processes, each small component again and again until the large problem is solved. That's called the iteration means. So we plan, design, implement, and blah blah blah. We implement all these 6 core processes in each um, each session, co-processor in each phase. So this is how the iterative system development works. We do some little analysis, we do little design, and we do little implementation. And based on the feedback, we can do more analysis, more design, more implementation, and then we even do more analysis, even do design. So we go little, something like that. So it's basically we go through 6 core process over and over again. So that's what it represents, this diagram. That's what I explained before. Okay. Uh, Most extreme versions nowadays, or now we have kind of in more adaptive version is this spiral kind of methods or spiral life cycle methods. Uh, so in the spiral process, the project is constantly cycling through the phases at different levels, and basically they give more emphasis to prototypes. Okay, even in the first iteration, they're trying to actually implement more to the users small prototype, and then second iteration, second prototype, and the third iteration, third prototype likewise. But they cycling through until the problem finish. So they actually start with the first iteration. Okay, so because they even the projects are there, we can't even successfully determine how many iterations we need. So we first determine first iteration and see how it goes with the prototype. Yeah, so the main characteristics of newer adaptive approaches. The iteration, yes, it work activities are repeated over and over again, and we focus on mitigating the risks. Remember the risk of losing money, or risk of having negative effects in project. So we focus in trying to mitigate. In each iteration, we trying to mitigate some part of risk. We trying to overcome some part of risk. And then the other characteristic is we focusing on the prototypes, right? Because the other good thing about the prototype is we can get very fruitful feedback from the user, because prototype actually represent a part of or kind of working software or working application for the users. So they can give a valuable feedbacks which eventually we can improve in the next iteration and next implementation. Um, so in this sort of newer versions, we assume that no one gets it right at the first time. Okay, that's the beauty of new adaptive approaches. But sometimes executives don't like it because it's never ending cycle. Sometimes they don't know when to end it. It keep going until, because sometimes some new problem can be emerged while we are working on the prototypes. Yeah. Right, so that's how we organize our system development activities, our 6 core processes based on uh, the characteristic of the project. So the next question is how we build the system, how we implement the system. Um, Again, there are two ways. We can go through a more structured way of implementing the system, or we can use more object-oriented approach. Okay, so it's actually um, very aligned with object-oriented approach, is aligned with object-oriented programming, and the structured approach more with more procedural programming kind of, you know. Uh, so in the structured, sometimes people call it as a traditional, but I really don't like the word traditional. It's still very popular modular programming approach. The structured analysis, uh, we identify certain things like events, and we build data flow diagrams like models, right? data diagrams, interrelationship diagrams, and then when it comes to design phase, we use kind of a structure charts for each event sometimes. Then we define the program modules, right, based on the functionality it performs. It also based on the data flow diagrams, and then we use appropriate language or structured programming language to implement it. Uh, yeah, so in the first part of your project and in our coming weeks, we actually focusing on the structured analysis. So that's how we goes for we study both of these approaches. Um, so the next couple of weeks, we focus on the structured analysis. How we going to, what is structured analysis? I mean, how you approach your project uh, in a structured way, what models we need, and how each components are interconnected, etc., etc. So I will re-explain this again when it comes to structured analysis. So basically, in the structured analysis, our main focus is on the processes and the data and the inputs, outputs of the system, etc., etc. So here the actually diagram plays a significant and I would say one of the crucial role in structured analysis domain together with data flow diagrams. So I will come to DFD or data flow diagrams maybe uh, next week or week after. ERD diagram you already know, right? So this is an example of data flow diagram. So these are the diagrams we are trying to draw in your project, uh, but as an individually for your system or the subsystem. So the idea about the project that you are doing, we have the case study. So the first thing is you need to build a system vision document as a group, as a team, and then each team member focusing on one functionality or one capability which reflect one or maybe bunch of capability or two capabilities sometimes to reflect one aspect of the system or one subsystem of the whole system. And you go through all these techniques like creating these DFDs and do other models, right? That's the basic idea. So individually we are building this, right? That's the requirement. Um, so we know that we build these ERD diagrams. So that's also part of our structured analysis technique. So that's actually shows the data processing aspect or data objects, what kind of objects you need to process your data in that particular context, isn't it? And then once we done the structured analysis, then comes the structured design. We actually trying to answer these questions like what set of programs should be, what program should be accomplished, how programs should be organized in a hierarchical way, which need to be programmed first, which is comes next, etc., etc. Uh, and that's what do you mean by structured designs or something like this. We design, but we are not going to touch design part because our unit, this requirement analysis modeling unit, are basically focusing on analysis but not the design part. Okay, and then the object oriented approach to system development is the next phase. So once we build our system in a structured analysis using a structured principle, we then move our focus into object oriented approach. So you are building models based on that approach as well. So it's completely different to structured analysis. We focusing on the objects, basically things. We give the object means your entities. We give prominence to the entities, the objects we trying to implement. Conceptually, there's no processes, no data entities or programs or files. We try to objects, we try to build the object, and we try to give a behaviors to the object. We try to identify the characteristics of the object. So that's basically what we are going to do in the under the object-oriented approach. So then we can implement in appropriate language like C Sharp or C++ or Java or VB, whatever. Uh, yeah, so the object-oriented approach is quite, different because it's basically start with the object and see what are the things the object can do or perform with respect to uh, the the request that it comes from the different other objects. So that's what we are trying to implement in object-oriented approach. So object-oriented approach also has object-oriented analysis and object-oriented design, um, and then the object-oriented programming. So we focus on the analysis part. We trying to define the objects and shows kind of use case diagrams and state machine diagrams. We use sort of different diagrams to show different aspect of the system in object-oriented analysis. So basically, this is an example of object-oriented approach where you first identify the object. So basically, this looks like kind of a ERD diagram, isn't it? Right, entities in the objects. But we can actually show some other stuff more than ERD. ERDs are very uh, there are some aspects we can't actually show in the ERDs, but in object oriented we can show more aspects. So I'll explain it later on. Yeah, and then we can implement it using object oriented programming language once we design it. Yeah, so that's how it works. Right, so that's the end of our lecture today. So today we learned different approaches to system analysis and design and what we mean by the SDLC lifecycle means, and we went through each phase little bit in detail, right? Um, and then I explained adaptive and predictive approach to system development life cycles and object-oriented and structured way of implementing the systems, etc., etc. Right, so that's the end of the lecture today.